This morning we will continue our IT Academy Research Summit with highlights from the researchers, and after that also hear a little bit of first reflections from the stakeholders and advisory board members. Before we go to the presentation, the speed dating website is still open until 11 o'clock sharp. Then it goes closed. So you can find the link on the homepage. It was on the QR code yesterday, but on the homepage you can find the link. That gives you opportunity for uninterrupted time with different PIs. I had to repeat, got a couple of times the question, who is PI? Yesterday, before I used that word, I defined it. Principal investigator, group leader. So in the scientific terms, people know that, but of course you don't pay attention when you have definition on the first page, and then in the later you will use it. So PI is a group leader, and they may have different ranks, lecturers, associate professors, full professors, researchers. Okay, did I miss any other information aspects? Speed dating page is up, use that. And first we will move to actually Institute of Technology and more on computer engineering side, and Arun Singh will talk about the collaborative robotics, please.
Okay, is it audible now? Yes. Yeah, good. So, hello everyone. Welcome to this morning presentation. And today I'll be talking about some of the challenges in robotics that we are trying to solve in our group, and what we have been mostly doing since last around four and a half years. What have we accomplished? I've collected a bit of more flashier demos that we had to show you what are the current state of the art and what we can actually at the moment as a research group can do with robots. Okay, so to begin with, so we are in the process of slightly rebranding our name to make our scope a little more broader, building a new website, moving the content to the new website with a new name. And as of now, the group stands we have 5 PhD students, we have 2 research engineers, master students come and go. So at the moment we have 1, but that number keeps fluctuating all the time. We have 1 postdoc, and this is a photo that was taken recently. There was some gathering at my home, and almost all members are here except Fatima and Igor, who were not present there. So just a bit small description about the group. Okay, so to begin with, what's our vision is to enable robots to perform efficiently in environments which are dynamic, uncertain, and unstructured. So what it means is you take a robot and put it in an environment which is slightly different than what it is what it has been used to, and it's still able to perform well in those environments. For example, you will see here there's a crowd here, and we put up a mobile manipulator with a base in this crowd. So this is from the demo that we had a few days back when the King of Sweden was visiting Delta. In this one, we have a bunch of a swarm of drones. We have around 16 drones here, micro drones, in a very cluttered environment. And how can we coordinate their motion? So this is an example of where, because the drones are moving, the environments keep changing all the time. So how can we make robots agile and adaptable to those kind of environments? And we have this classical example of this very dynamic environment, which is a traffic scenario. So you have this vehicle moving in a very dense and potentially rash traffic where others can cut into your lane, or you have to overtake. And So so you have to make decisions very fast, and you have to take the nature of like some uncertainty into account, and you have to take into account that what you take a decision now needs to be adapted pretty quickly because the environment or the scenario has changed. So our vision is to make robots seamlessly operate in this kind of environments, and that's what we have been focusing on throughout the last 4.5 years. And we have demos of all these three things and the others that we have been doing. So just to give a glimpse of a small demo of what exactly I mean by this challenge of unstructured, unknown environment. So on the left, so it's a small demonstration that we had where we mapped the third floor of the Delta building, and we just used an off-the-shelf algorithm, did some tuning of the parameters, and we were able to get a robot. So this was like 2 years back, so that's why you see Human here wearing a mask. So we could make a robot autonomously navigate the hallways, see it could avoid even like a dynamic obstacle, and could do it pretty well, like at like max speed of around 0.7 meter per second. So this is what you can achieve not so relatively easy in robotics. So you have this kind of environment, pretty much static, things don't change. You have it, and then you map. You make the robot is fairly certain of what it has computed offline actually still holds. The global plan works, and you just do minor modifications here and there while moving. So this kind of situations robots are fairly good at, and that's why you see these manipulators in factory floors, which does very, very exceptional work because the situations doesn't change, the scenario task doesn't change. And on the right, this is a small simulation video where the robot does not know what the environment is, and it only uses this LiDAR to on the fly take this LiDAR point cloud and needs to figure out how to navigate this highly cluttered environment. So it has a partial understanding of the scene, so it goes and sees that, okay, so there is open space somewhere, but actually when it goes there and sees further, it gets stuck. So there is actually not enough space to squeeze through it, and it actually will stop there because it mistakenly thought that it's a free space. And so one more thing that is play here is that the robot is also looking at a very short horizon. So it's looking like around 2 meters in front of it. So it's not taking into account like what is the point cloud, which is like further away, like 10 meters from it. So these are the kind of situations where robots, like if you deploy a robot, whether it's mobile robots or a manipulator, they typically struggle. So because they have to take into account like how does the environment change or the part of the environment that they have not seen. Let's say they have just sensing based on LiDAR point cloud, and then they have to use that to do a very adaptive on-the-fly decision making. So these are things where it typically gets stuck, and these are the kind of problems that you want to solve in our lab. So I'll give you like a pretty broad idea of how we solve, how we have been trying to tackle these problems. And from the very beginning, our aim was to take a very abstract approach. Abstract not to say it in a sense that it is unrealistic, or abstract not in the sense of abstract pure mathematics like that, but abstract in the sense that an approach where we abstract out the details and take it to a level where we develop one approach, algorithm, then that works for a very diverse class of problems. For example, I can apply it to navigation, I can apply it to manipulation, it should work on autonomous cars, it should work on mobile robots, drones. So we started taking, we had that mind. So we had that in mind that we'll do this kind of abstract high-level approach where we would develop algorithms that generalize to a diverse class of systems. And two of the building blocks that we had, and that these building blocks represent the general theme of the research that me and my students do. So the first block is accelerating the underlying computation. So every robots, when they make decisions, at the very nitty-gritties, they solve some set of equations. Okay, so it can be most of the time it's like an optimization problem. So they solve some numerical computations to solve these optimization problems. So a great deal of our effort has gone into, so how do we make those optimization problems? How can we solve those optimization problems faster? And how can we make their solutions more reliably obtained in real time? And how can we come up with reformulations or rewriting of those equations so that we are able to solve it? And more specifically, the one interesting thing that we did was we tried to look at problems where how do we rewrite a certain set of problems, a certain set of equations, so that it leverages the underlying computing architecture. For example, things that run fast on GPU need not run fast on CPU. Like you have these GPUs and computers which are very good at doing one specific computation, which is this matrix products or matrix vector products. So how can we build like optimization algorithm which just does that and nothing else, and still fast and reliable? And how can we parallelize those things? So those are the tricks that we have been developing to make these computations faster and more reliable. And the second building block that we have been looking at is like how can we, what we call is the control theoretic artificial intelligence. So like in robotics, you can give robots and show robots how to behave. And if you have enough amount of data, they will learn from that data. They learn this behavior from this data. But usually what happens with deep learning is that there's no guarantees. Like if it works in one environment, what happens in this environment changes. So we are trying to see if we can bring in this classical control theoretic perspective, embed into as like very strong prior knowledge into more data-driven deep learning algorithms. And that's one of the things that we have been doing, and we have got some success in autonomous driving and manipulation with respect to that. So now I'll show you some demos, and I'll tell you what some robots moving, and tell you what are the things that we did in those kind of demos. So I'll first start with this swarm demo. So we had, this was a collaborative work with TU Munich and University of Toronto. So I had a student who went to University of Toronto for masters, and that's how his collaboration set up. He continued the work that he was doing with me. And so here you'll see a swarm of drones interacting in a very tight space. They have to move from one place to another without colliding. So there is free space transition. There would be, like you should put like a pretty cluttered space. So here the main thing was so because there are several drones, not only one robot, so the search space is very high. So how can we decentralize the search space? How can we develop distributed algorithms that takes into account, like let each robot does its own thing, but still is safe. So that was the main thing here, like computing distributed algorithms. And towards the end, you'll see a demo where actually it interacts with a human also. So it's able to, the swarm goes, like separates out to make way for humans to move. Okay, so this is one problem state. So this is my PhD student Human's PhD thesis, where he's looking at navigation problems with visibility in mind. Like how do drones move such that, or rather any robots move, so that they keep a particular thing in field of view. And potential application is this drone cinematography, but here we are doing it in a highly cluttered environment. So you will see here Human trying to actively block this drone's field of view by bringing in obstacles or changing the obstacles. And drone's task is to come up with its motion or action plan so that it maintains visibility, or in other words, prevent occlusion from the obstacles. So it figures out where it actually should move so that its line of sight is free. And so here also you see that the environment is continuously being changed, and it has to do this on-the-fly decision making. And the target is also continuously moved. So here the main thing was like, how can we do this fast planning? And we had like a novel way of modeling, given an environment, how do you model occlusions or blind spots in this environment, and then use that to do planning. And this was like an extension for that work. So what we knew that we can do this visibility planning, like we can maintain, while moving, we can maintain some things in my field of view. An obvious application of that, we thought, was in warehouse inventory management. So like we have drones which can scan warehouse racks, read the barcode, QR code, and then do this inventory management. The problem was that the drones, if you have a very bulky drones in warehouses, it becomes difficult to use because it's a very narrow spaces are there. So we thought that we can couple a drone with like a UGV, like the blue is the ground vehicle, which has, let's say, a LiDAR on its and more computing resources. So the ground vehicle has to guide the drone to actually follow and scan the warehouses while avoiding the obstacles and maintaining visibility of the racks. So you see in this this part here, you'll see here the drone. These are the warehouses that you're seeing. This is like the top-down view of that scenario. Here, one of the cool things that we did was actually we fused some like learning with more classical planning to make this process more faster. So this was a small like a practical or real world demo implementation of that we did for the paper. Here you'll see that. So here it has to scan that yellow line, and there are obstacles in between, and then it has to avoid those obstacles. And then each of one, both the ground vehicle and the drone needs to have a field of view, keep each other in the field of view. And we had this demo yesterday, in live demo in that room, in room 2024, and some of you were there to see it. Yes, so this is another example of where the environment changes fast. So we want to have robots operating in households and airports, malls. So in all these places, there is a crowd, and we have to take into account that the robot needs to weasel through crowds and not collide with them. So this is like this video is a simulation where these boxes are the positions of the crowds being tracked. And then this pink point that you see is the ground robot that needs to move around while taking into account the predictions from the crowd. And this is like one of the like a very challenging problems that people are trying to address because it has immense potential. You can put this in. If you put robots in like malls, warehouses, and households, or any like environments where humans are, it can be a great assistive device. You can use it to transport objects. You can use it to guide people in say malls or hospitals flows. So this crowd navigation is one of the like a very hot topic currently in robotics, and as I said, the core challenge stems from the nothing is fixed here. Everything keeps changing. And whatever you have thought of before, prior plans, offline computed plans, no longer is valid. And this was what we had in. So what we had here was a very basic version of what we are developing in what you saw in the simulation. But it could work slowly. It could not collide and like gradually navigate. We want to do this, what you see in this demo, but we want to do this at a very high speed, but yet safe. Like how can we make it move faster, but still at the same time not collide with humans or not disturb them? So we need to do this kind of what you call the long horizon planning. You need to see through your LiDAR and then start thinking 10 meters or 10 seconds ahead into the future, make this kind of long-term prediction. So that's what we want to push this up or like take this up a notch. Okay, so how much time I have? 2? Okay, good. I'm almost towards the end. So this was a real-world development. I'll just quickly go through. So this was one of the projects that we kind of are very proud of because we actually demonstrated that if we can get this whole pipeline up and running in an environment where, in a very real-world environment where we cannot control many factors. So there. You see, we did this hack of using a Raspberry Pi to open doors. Does put something here, and then it will go and transport it to this a particular lab. Again, so we want to push this up, like to do it at a higher speed, so to make it economically viable. Because the speed, I'm not so happy with this speed. It's a very good demo, but I want to push this up a notch so that to make it really, really good. This is one example on the manipulation side. So here the task of the robot is to arrange objects in particular order. So it needs to think which object it should pick first, which should pick second, third. It's called the sequencing problem. The main fundamental challenge here is that we define objects distance by how far they are in the Euclidean space, but for the manipulator that doesn't hold. Like if you, so what is close for the manipulator or what is far depends on how your manipulator is positioned. For example, if your arm is like this, you cannot, even if the object is very near, you cannot pick it and place it. You cannot go towards it. So it depends on how your arm is located to actually define this notion of what is close to you and what is not close to you. The technical term for this is that this all, so you have to go from this, this Euclidean notion of distance to a manifold notion of distance where things lie on a manifold or a surface. And there, so here, to do this fast sequencing and like correct sequencing, we learn this, this notion of distance from data. And then we use that to do this pick and place operation in a real time. And we show that it improves this overall performance a bit. Yeah, so this is the last demo. We trained one agent to be very fast and aggressive, but yet be safe. So you wanted to see how fast you can move in a very dense traffic. Don't worry about rules, but very fast and how, but not collide. So you have to see what can be the possible limit of this. So this is what the initial results for that. So we trained one agent where we had this this pipeline of what we call the control theoretic AI, where we embedded some of the optimal controls priors into this kind of like into the supervised learning pipelines and self-supervised learning pipelines. Just to quickly summarize, so so we have been doing relatively well. So we make a point of publishing at the right places. So on an average, we get 4 to 5 papers in the like top 5 or top 4 places according to Google Scholar Index and robotics field, and we've been fortunate to be able to do that consistently. So yeah, just to conclude, we have been trying to get robots operate in unstructured and dynamic environments. We have solved quite a bit of problems, long way to go, and we are continuously looking for industrial partners or end users or any kind of collaborations. If you find this interesting, you want to reach out to us, then feel free to do that.
Do you publish everything open source, or do you have code repositories, or how do you share?
In terms of papers, some are open access, some are not, depending on the kind of grants we have. But the source codes are all open. We all put everything on GitHubs and stuff like
that. Very nice demos, both simulation and real life. So how much of a problem is it in your work to go from simulation to real life with a particular solution or algorithm?
Depends on the application. So for some applications, it may not be that much challenging. So like for example, if the robot's own dynamics changes, that's a very big challenge, because so what you have, so that's the fundamental building block. So if you ask a robot to do something, and if you give some action, how does it react? So that itself is the biggest hurdle, because the simulation physics doesn't capture the real world physics. That's the biggest challenge. The second biggest would be the interaction. Like for application specific, if I give an example, like autonomous driving, interaction is one of the key challenges. Like simulation I showed, so the neighboring vehicles have a rule-based approach. So they have some rules, do lane change only this. So that doesn't capture the actual interaction that we'll have with the environment. So for that application, that would be the sim to real challenge. Same thing goes for the crowd, because the interaction is very difficult to model and learn. For manipulation, like simple pick and place, the sim to real challenge is not that much, because here it's fairly, the challenge lies somewhere else. For drones, again, the dynamics is the key thing, because there would be wind. And if you take it in an environment where there is a lot of wind, then your dynamics model don't work. So that could be one of the challenges for sim to real in that.
But in this simulated car overtaking speeding approach, you could make all the cars running the same algorithm. Everybody tries to overtake everybody
Yes,
else. What
yes.
happens then?
So that's one cool way that we can do that, but the problem is that we have to make that scalable to simulate that kind of idea. Like we have to make all robots, so you have to simulate hundreds of that, and all of them are doing complex decision making. So your simulation, each simulation should not take half an hour. So each step should not take half an hour. You will forever be doing simulation. So you have to make the simulation, simulator itself needs to become better by making doing complex modeling, but still being reasonable enough to be used to develop something. The simulator is fast enough. So that's also one of the challenges that we are not explicitly handling, but that people are looking into that, to build great simulators, to bridge the sim to real gap.
Okay, no further questions. I don't see it at the moment. So let's thank Arun again. Thank you. And we move on to the Eduard Ševtšenko about digital supply chains.
Okay, good morning, everyone. Oh, okay, so we can start. So I speak about the activities of our digital supply chain research group. So what we've done so far in the field. So our main goal is to digitalize the supply chain and to find out how we can use latest Industry 4.0 tools, for example, to increase efficiency of supply chain. So we're decreasing the costs, increase customer satisfaction and service quality. And our main task was first of all to understand which tools we can use to make improve leanness and agility of supply chains. So we analyze different tools, find out which one are the most popular today in the companies and which one are more popular today in research. And some of them, of course, went together. So it was quite useful. Then we also elaborated the framework how to start with supply chain digitalization and how to find out which tool to which process should be applied. And for this purpose, we're actually working on performance metrics. So we need to measure supply chain overall and then each process more deeper. Small timeline of our research group. So I started here in August 21. Then first with teaching, then I get one PhD student to my team. Then this year already we started 2 area projects. So we're also dealing with digitalization in furniture business. And next step will be to get one industrial PhD, what could be funded by STPost. And the idea here will be to make this optimal route planning for maybe partial and periodic deliverables, because the task is changing routinely, and then we need to recalculate it. And I do also some international research with partners. So first of all, a little bit about this current research. So what we do, and we have several partners inside. And the objective here is that we would like to find the way how to make digitalization of supply chain more efficient, how to find out which tools and which processes we should apply, and how to predict that those selected tools will be efficient before we will implement them. So here is our vision. So first of all, we take the data related to customer satisfaction. For example, like customer delivery accuracy, maybe reclamations, returns. And then we map those problems with core business processes. So for example, if something happened in production facilities, then we put maybe make produce. Then we add also the KPIs from the score, and we compare the KPIs of score with KPIs of company. So here we can make the recommendations that which should be added, which can be removed. And after that, we can model the current process and move towards new process. So we just apply, maybe we take one tool out, another tool will come in, and then we can show how it will affect the efficiency of supply chain. This is the main idea. So basically from the left side, you can see the score business processes. From the right side, the real processes of supply chain. So we try to map it on different levels. First level is more like supply chain level. So all processes starting from procurement till delivery of items to the customer. Then we go deeper inside, and each level we can map to KPI of score. It's like supply chain operational reference model. So this model is used more than by 500 companies in the world. So it's quite advanced model. And on the last level here, we can try to add different tools and improvement activities. And then we show how it will be implemented in current operations. So this is like level 1. So in level 1, we can see main business processes. Then we can see also how we map the current processes with score processes. And then we also can map the KPIs. So in this last slide, you can see the strategic KPI and then first level KPIs of the company. So you can measure efficiency of your supply chain. Then we go deeper. We take a process out and we will map deeper until we find out which is this lowest level KPIs, which can be measured directly on operational facility. So if you want to improve something, here will be the actual input. And then we can track this input like out. So result will from fourth level we go to level 3, then level 2 and level 1. If all of them are efficient, then efficiency of our supply chain also increases. And then we also made case studies. We took two kinds of businesses. One will be garment production. So you can imagine that requirements for garment production not so much precise. So if you can put this jacket on, it's quite okay. And if you compare it with electronic industry, then actually here it's, if I put maybe this electronic mirror to my vehicle and it will not work out in the traffic, then it will be disaster. So that's why the model should be able to satisfy both requirements. And this is our creation. So this is like BBN like structure. So what we try to show here, so in the middle we have this strategic target and second level KPIs. Yeah? So we show like how reliability of supply chain depend on those 4 parameters. Then those parameters are connected actually to the third level KPIs and then to real business processes. So we can see how business process influence our supply chain efficiency. And what is the advantage of this tool? That when we do some kind of change, so we actually can ask from the system what will happen if I will modify this tool and the reliability of this current business process will be improved. So I see like what is the reaction of supply chain on that. So after that, we actually discovered that in the company, not all of them used. So it will be just small algorithm how to clean up and to create like something like this. So this is like real KPIs worked in the company. And here we also added these corrective actions. And then we can check how those corrective actions influence our KPIs, and then we see what will happen with our supply chain. So currently we took only reliability, but our target will be also to take this next ones, like cost, maybe this agility, and also we want to see like how fast we can react maybe to the desires of our customer to make maybe more lean our process, to make it faster. And then research results. So recently, last paper was accepted to the journal, and currently my student on this first year of education, and we published so far like 2 1.1 papers, and then we have 2 3.1 papers, and then 2 in progress. So he will also go to the conference of PhD students to Portugal. So we'll speak about results. Then other research results not connected to our IT Academy. Also was like one good sign that we're actually on the right way. So here we spoke about how industry is using 4.0 technologies, and we investigated here like theoretical aspects and also how companies today are using and how consulting companies apply them. And this was quite interesting that there is still quite a big gap, so we can still move in this direction, so it can be done better way. Then some population science. So this is just to motivate people to use our approach. And some collaboration with industry started. So currently we on the progress is this Erasmus Plus project, Digital Supply Chain 4.0. So on this project, actually together with Latvian and Lithuanian universities, we designed 15 courses. And courses are expected to educate companies how to use those different supply chain digital tools. Then we also collaborate with Playtech and Helmes, who participate in our lectures. So we have very good practical examples from the companies, which students like quite much. Then we have companies who just provided us the data. And now we have also the company who provided us two AI projects. So we will check how AI can help in production process planning and how we can automate activities that today people are struggling with. So our aim is to free a little bit time for other, maybe more interesting activities. And now we also will participate in this procurement preparation for ST Post, or the network of several companies, and Omniva is one of them. And here we want to assess what kind of software should be procured that you can do this process better in ST Post. And if it will be successful, then we can have a PhD student who will actually do some intelligent part inside of this software. So what we try to help, and this will be also our wish and motivation, that we want to help companies to be more efficient because they know how to apply the new digital tools. And we also created the network which is able to calculate and predict what will be the effect of implementation. And then we're working out on this new topic for new PhD student. And this will be about this self-learning algorithm. So we take existing software and develop the intelligent part that will make this recalculation of routes based on current situation each morning. And then we know how many cars we need, how many people we need, and if able to deliver all kinds of packages, periodics on time. Yeah? Okay, that's it. Thank you.
I have the question about, does your model take into account also the security issues to help, for example, with service level agreements or something like that?
So it's possible to take, but currently what we considered only what companies provided to us. So the security issue is definitely very important, especially we had the case with one company that we wanted to collaborate, but somebody hacked this company ERP system, and now this company was actually down and they will not provide us this information. So this is very critical actually today, and could be one step that we need to consider.
Before Melis asks, I have one question. So these business process models, they look very kind of static in a way. Yeah? How much self-adaptation there is in the dynamic environments in this kind of field, and can you apply some dynamic optimization and maybe machine learning AI on top of there?
So machine learning, this can be like one of the tools actually what we can apply. What we do currently in this IRA project, so we first take this static process, we describe like it works today. So we show like each operation who is doing what inside. Today it's static. So they do in such way that each product have one bill of material and have one routing. When we apply AI, it will be dynamic. So system will check out, is it possible to produce in different places? And it will be maybe up to 12 different possibilities to go, not one path, but different paths. And our vision is that the system should assess based on customer preference, for example, minimum price. So this is the one. Maximum load of equipment. This is the one. So we take this one, which is the best in current state, and then send it back to ERP system. And then it will be like dynamic. So maybe each time the same product will be produced different way. So it will depend on the current preference of the decision maker. So this is quite critical.
So I have a question about what you can do with the diagram. So you mentioned supply chain efficiency, but I'm wondering about robustness. I mean, recently there have been many problems with supply chains, and so I'm wondering, like, can you analyze whether the particular supply chain is robust towards a single point of failure, some vendor not delivering? Can you analyze these kind of risks and robustness there?
Yes, actually, it's quite also important topic. So far, we concentrated more on this reliability. But the second one can be this responsibility part. So where you actually promise something to the customer, he should receive it on time. So the same issues we actually have in the same company, what we actually work on. And today it's solved in such a way that the company try to give the time and not change this time for the customer. It doesn't matter what happened with you. So in this case, for example, if you don't receive the material, maybe you can receive like some part already produced on the market. So price will be different. For company, important that this what is promised to the customer still fulfilled. And in this way, actually, what we need to measure this responsibility of all your partners. So all of them should be on the same way. So if something happened, or even like predicted that something can happen, they can give us information that yes, here's some risk. And this we also checked in previous PhD thesis, what was defended me before years ago. And this was also idea that we have different partners inside, like preferred partner, and then some additional partners. And if something happened with this main partner, then we can just take small portion and give over to others. So maybe today what could be done that minimum 3 partners per product or material type should be. Then maybe we can deal with it.
Thank you, Eduard, again.
Okay.
And we will move.
Thank you.
And we will move to the next and actually last presentation from the researchers from the IT Academy. Naveed will talk about autonomous driving.
Thank you. So I'll begin with a question. How many of you think getting a driver's license is annoying and hard and unnecessary? And you look forward to a future where all the transportation will be autonomous, and you won't need to bother with getting a license. Okay, so there is a few. And are there any people here who love driving so much that they're actually worried that autonomous driving will take this opportunity, the joy of driving away from you? Okay, so there's a few. Okay, so I have good and not so good news for all of you in this presentation. So I'm Naveed Mohammed. I co-lead autonomous driving lab here at the institute with Tambet Mathiesen. I actually came here in 2019. So we set this lab up in 2019, and at the end of 2019, I joined the university. And yeah, it's the IT Academy program has been really key in me being able to come here and set up a team. We hired many colleagues after that from the same funding. So before I move on, I'll try to spend a minute on what autonomous driving actually is. So I suppose many of you know what autonomous driving is already. There is many benefits that autonomous driving actually offers or promises. So when autonomous driving is matured, then the biggest advantage that it promises is the safer transportation infrastructure, safer roads, because 95–97% of the road accidents, they are because of human error, and that aspect will be completely eliminated when all the transportation is autonomous. But that future is far, but of course, that's the promise. And along with that, there is other advantages. And autonomy in general is divided into 6 levels. 0 is completely manually driven vehicles, no automation at all. And 5 is completely autonomous in all sorts of driving conditions, no geographical limitations, no weather conditions to be complied to. 4 is the same as 5, but with some restrictions. And to give you some idea where the current state of the commercially available vehicles is, Tesla autopilot is at level 2. So that's where the responsibility is all the time with the driver, not with the vehicle. So with that being said, I would move on to the main topic of the presentation, which is autonomous driving lab. So in the lab, we have a threefold focus. We focus on education, technology, and research. And that's how I have set up my presentation. Also, I'll talk about all these 3 areas one by one. So I'll begin with the technology. in the area of technology, there is two aspects that I would like to highlight here. One is that we try to evaluate the state of the art, basically in autonomous driving ourselves. How does it actually stand with the claims made by the new algorithms that are coming up. Also, so we have this real-life autonomous driving test platform, and it's fitted with the state-of-the-art sensors, and we keep adding new ones. And so one aspect is we keep evaluating the state-of-the-art, and the second thing is that this platform also helps us validate whatever new algorithms we are developing, whatever new investigations we are conducting. So we don't only, on offline data sets validate our research, but we can actually go out on the road and conduct experiments with this vehicle and see how our new investigations or new algorithms stand. In terms of validation of the technology, almost 1 year after the lab was set up, we did our first street demo along our demo route here. So this is in the center of Tartu. So we leave from Delta, go all the way to the Kvartal, the intersection, then come back. So this demo was conducted in 2020 September. Fast forward almost 2 years. So last year in spring, we conducted public transportation, on-demand public transportation project in collaboration with the city of Tartu, with a few companies, Trafest, Berkman Technologies, Modern Mobility. So for this project, the idea is that people can request, just like they could request a normal bus for public transportation purposes, they could request our vehicle. And for this project, we had to map the area here. So this is Vorbuse Tiksoya area near Tartu. We had to map 66 kilometers of lanes, and the route contains 26 bus stops. And the idea is that you could go from a passenger could request to go from any bus stop among these 26 to any other one. So that was the idea. And we learned a lot of things. So in total, we had 21 rides, 33 passengers. The key point here is that we had, the takeovers by the safety driver on average were every 1.3 kilometers. Along the 331 kilometers that were driven by the vehicle in this project, in this experimental study. So what it shows is that 1.3 kilometers doesn't look too long, right? So in these 331 kilometers, every 1.3 kilometers, the safety driver has to take over. So you might think, what's the challenge here? What's the biggest thing making the safety driver take over? So the biggest challenge in this study for our vehicle, as well as autonomy in general, autonomous driving research, is the human element. Whenever you need to take decisions, given the pedestrians around you, the other manually driven vehicles around you, that's the biggest challenge in the field in general. And that's what happened here also. So for these 252 total takeovers along the whole 331 kilometers, more than 50 were because of stop lines where you have to give way to other, you have to stop and basically see if there's other vehicles approaching, and then move on with your drive. And then around 38 were for pedestrian crossings. So so this human element is still the biggest challenge. Moving on to the education aspect of autonomous driving lab. Basically, the aim here is to build workforce for the industry as well as academia in autonomous driving. Here in Estonia, as well as worldwide, there's a big industry in autonomous driving. It's continuously growing over the last a decade or so. So we here in different curricula, we have courses on autonomous driving. We also have a bachelor, master, doctoral thesis going on. When we started in 2019, it seemed like a dream that we will have our own students, our own graduates joining the lab and working with us. And now we have many. So we have, of course, bachelor and master students who are a part of the lab and working, and doctoral students. But also, for example, my most senior doctoral student, he's in his third year. His fourth year is starting this fall. So so one side note here is that we are going towards a situation where our own graduates can make our own team grow with senior members. So in this kind of the programs like IT Academy program are very instrumental here also. So this was a side note, but moving on, in the education, we also hold competitions. For example, we have a competition that we have been holding for 3 years on small scale vehicles, where small toy cars, they are driven autonomously in this kind of a toy city environment. And this year we also are organizing a competition where data from the rural roads, so Rally Estonia tracks, that data will be used to train, the participants will train machine learning models to run a vehicle autonomously using the data collected from these rural roads. And then the top 3 solutions, we will also take them to be tested in real environment on our test platform that I showed you earlier. Another aspect of education that we are working on is also developing autonomy software. So a little bit more details about that. There is actually many open source software stacks that are available for autonomous driving education and research. For example, AutoWare AI, AutoWare Auto, and also Apollo from Baidu. The problem with them is that they are huge. They are very often complicated for students to start working with these software stacks. They are often in C++, and students are more trained in Python, for example. So we are creating this software stack. It's now released. You can actually, there's a link here. You can go and check it out, check the details. So basically, it's based on Python. It's easy to set up, and very smooth and easy entry for students to start working with autonomy, as well as it's fully capable of performing autonomous driving research. The software stack is very modular, and we aim to use it more and more now for our own research in autonomous driving. So that actually leads me to the next part of my presentation, which is about research. So in research, I'm going to talk about 2 things. First, I'll just mention different research areas that we are investigating at ADL, and then I'll give some highlights from my own research in autonomous driving. So looking back at these 5 levels or 6 levels of autonomy, in terms of research, this is where the focus of the lab is. So when we talk about research, we are focusing on full autonomy, either at level 4 with restricted geographical zones and weathers, or level 5, so full autonomy. We are investigating many areas. So some of the main ones are mentioned here. So behavior prediction is one, educational technology, mapping localization, human-vehicle interaction. This learned driving is basically completely machine learning based solutions to autonomous driving, so on. So we have many great colleagues. Some of them are here in the room who are working in who are leading the research in different areas mentioned here. My own research mostly is in relation to the 3 areas that I have highlighted here. Behavior prediction, motion prediction, a little bit on mapping and localization, and a little bit on perception, not perception uncertainty per se, but perception. So I'll talk a little bit about that now. So as I mentioned earlier, when I was talking about the on-demand public transportation project, one of the biggest challenges in autonomous driving in general is the human element. how do you predict the motion of other humans, and how do you make decisions, appropriate decisions based on that prediction of other agents' motion. If you have a vehicle that drives at 5 kilometers per hour fully autonomously, that's not a very useful vehicle. You want to drive efficiently. So for that purpose, you need to be able to make predictions of how others are going to behave in next 5, 10, 15 seconds. And that's where this behavior modeling and motion predictions come into play. So just one highlight that I will show you in this area is this state machine that we recently developed and incorporated into our Lexus test platform also. In addition to that, we have worked on modeling the behavior of bicyclists and their interaction with the vehicles, modeling the behavior of vehicles at roundabouts, etc. So there's many different sub-problems in this area that we have worked on, but this is just one highlight. In terms of mapping, we have worked on creation of high-definition maps and changes in maps. I will not go into detail about that, but one work that I'll talk about a little bit more is this ongoing work by one of my doctoral students, Kumar. So here in this work, we are working on perception in harsh weather conditions, which is very, very relevant in the context of the Nordic region. So you have all sorts of weathers, you have snow, and also it's even if you have really clear weather, you can always have sun glare, for example, that can completely blind your vision, and you need to still be able to detect what's around you, be able to track the agents around you. And the interesting thing here is that this perception part is just one brick. The idea here is bigger than that. The idea is to perform localization. So you, as a human driver, let's say you're driving from one city to another city in Estonia or in another country that you're visiting. If you lose access to your GNSS navigation device, you will not be completely lost, right? If you have a paper printed map and you can just see the road signs and street names and unique buildings, for example, you will be able to navigate from one point to another. But let's say you have a level 5 vehicle, and that level 5 vehicle has a child traveling in it alone, and this vehicle loses access to its GNSS navigation capability. It shouldn't just break down, right? So the idea here is that using the vision, using the perception only, and given a map without relying on GNSS, a level 5 vehicle should be able to navigate its way from one place to another. So that's the aim of this work. And we have also been conducting some exploratory research, for example, using flow sensing for perception in scenarios where LIDAR or other perception modalities might not be very sufficient. So with that, I'll conclude my talk. So the take-home message about ADL, our focus is threefold: education, research, and technology. In research, we focus on level 4 and 5 of autonomy, so full autonomy. In terms of an outlook for autonomous driving, as you saw, so there is more and more promising research happening. There will be more and more partially automated systems, like the systems at level 2 and also at level 4. So which will offer vehicles with full autonomy, but with very restricted conditions. So for example, just one street or a few streets or one route in a city. But the level 5 vehicles, they are far in the future. So we will not have a level 5 vehicle tomorrow or in 5 years or even I think in 10 years. Another thing that makes it complicated is, let's say today, all the vehicles, they become autonomous magically. The vehicles that were sold yesterday, which were not autonomous, they will stay on the roads for next 20, 30 years. So for next 20, 30 years, there will be a mix of autonomous and non-autonomous or partially autonomous vehicles, right? So in that future, for a few decades, there will be all the challenges of human-driven vehicles that the autonomous vehicles will need to cater to, need to take into account. So it will be still a challenging scenario for autonomous vehicles to be operated in. So yeah, those who really love driving, their driving licenses and the joy of driving is not threatened at all. And I will, one last point is that here in this region, we are really fortunate to have all sorts of seasons to be able to perform autonomous driving research that is applicable in a large part of the world. So if you are in a place where it's always sunny, of course you can do research, but then you might be it might be hard for you to transport to transfer that know-how into an area where like the winter is all snowy. So here we are lucky to have an environment where there is a diversity in environmental conditions, and we can do autonomous driving research. And also in Estonia, the legislation is very friendly. When there's need, you can always approach the public authorities. So yeah, so we are happy to have this lab, and the programs like IT Academy, and we look forward to conducting more fun autonomous driving research. Thank you very much.
You did not talk about this toy car level. What's your take on that?
So basically on the toy cars, so there's this kind of so we have toy cars that students can use as autonomous driving test beds, and very easily in comparison to, for example, using the big Lexus that I have shown, conduct autonomous driving research as well as autonomous driving studies that might not be research projects, but just engineering or more applied projects. So I think it's a very, very promising way to get the students involved in autonomous driving research. They don't have to, they don't have to be reluctant that they are handling a very big vehicle. And of course, the time that's needed to set up an experiment with the Lexus that you take out on real roads and drive is very huge compared to a toy car that you basically make run on this kind of a toy city and perform similar experiments. So I think it's a very, very promising way to get students involved in autonomous driving research for sure.
Yes, so thank you for the nice presentation. So my quick question is that, well, there is a lot of different players in this autonomous car thingy, right? And then, well, all of your research, as I can see, is focusing on performance, but then, algorithms for localization, planning, and all these kind of things are proposed like by a lot during all these years. So what will be like, the key aspect that we excel when compared with other players? What we can say that we are really good at when compared with others. I don't think it's performance because, performance, there's other lot of different teams working on this.
Yeah.
So then the improvements in performance, if we can have or find some, they will be minimal.
Yeah, so one of the things I can highlight is that, when you are a company, so when you are, for example, Waymo, which is a Google, self-driving, so it was Google self-driving cars, it turned into Waymo. Or if I talk about Tesla, when you are a commercial entity, you have, of course, more resources to spend, but you are confined or you are basically restricted by a business model, right? So your focus is not at the very futuristic, leading edge research, but more on the cutting edge. So this is a restriction that we don't have. For example, that's why we are focusing more on levels 4 and 5, whereas many in the industry, they are working on level 2 and 4, not at 5. So, I mean, of course, there is industry players also who are working at 5, but this is one key advantage that we have, that we are very free in looking at the longer term picture and trying to solve the problems that will arise, that we see will arise in future, that the industry has not started to work on.
Okay, thanks. And just one more a quick question. So I just wanted to know your take on, deploying these kind of technologies in Europe, because, for instance, other type of technologies, like for instance, metaverse has, has a hype here because of all these data privacy issues, trustworthy AI, and then these things can actually work. And then, there is like in Asia, also metaverse from different cities, but then of course, they don't cover these AI issues. So how do you see it here?
If I understood the question correctly, you mean there might be privacy issues with the autonomy?
Yeah, so then you were saying in your presentation that there is a lot of, human things to be aware of. So for instance, the trolley problem that it's, typical in autonomous cars is like you can deploy these things with current state-of-the-art technologies, but then you get into issues when you are applying these kind of, decisions that involve human lives. And then for that, the regulations that currently Euro have is that, well, you need first tools that you can use to basically audit and account these kind of technologies. So what will be the take on this?
As I very quickly hinted in the presentation, and I can elaborate now. So legislation in Estonia, for example, is very flexible in the sense that the government authorities are very open to actually listen to you and give you the flexibility that you need, which might not be the case when you are in a bigger Western European country, for example, or another country in the world. So this is one advantage that we have. And this thing is also, I think, good because the public authorities in Estonia can then reach the European counterparts, like Arnish was talking about yesterday. How the public authorities here. So their team themselves was not able to reach out or basically convince the European authorities, but when they got in touch with the Estonian government authorities, they could. So the point is that I think the legislation will also evolve. So EU is also working on autonomous driving regulations, and there is hope that things will evolve as the technologies evolve. I think my time is up. So
thank you.
Yeah. Thank you very much. If you have more questions, I'll be here. So
yes,
please.
We are around in here, and we still have the poster session and speed dating. Indeed. That you have still 35 minutes to register to. Okay, so we will move to the next phase and start hearing a little bit of reflections back. First up is Mart, who has been with the ITL during this program inception, and now with the Enterprise Estonia. So Mart hopefully gives some broader Estonian IT industry related background, feedback.
Yeah, so thanks for having me, and gonna talk about, as you said, a broader picture and in some areas related to IT Academy. Currently, yes, at Enterprise Estonia with the applied research program, and this program is supporting Estonian companies in applied research, and so it gives us a quite nice overview of what happens in R&D in industry. And here's an overview of the projects that we've supported so far in the program. 3 big calls, 75 projects funded, divided into sort of technological areas like e-health, artificial intelligence, energy storage, things like that. Each, on the x-axis, you have estimated growth potential of each technological niche, and the y-axis has a number of projects funded in every area, and then the bubble size represents the volume of the project. So the largest in terms of volume is the yellow circle, which is drug development, mostly or actually 100% preclinical drug development. And the most popular fields in terms of number of projects are e-health, artificial intelligence, automatics, robotics, all these topics that we heard about in the past 2 days, indicating that the research you do here is relevant for the enterprise as well, or industry in Estonia. And although the program aims to support companies can decide to collaborate in these projects. And as you can see, with the total funding we've handed out, it's a bit over 58 million. And out of that 58 million, 11.14 million has been allocated to the universities, either through partnerships with the companies or through service providing or something like that. Anyway, it shows that universities, or companies rather, want to collaborate with universities, and they need the universities' research, excellent research to help them develop products. In addition to funding and technological consulting support, our team has also been involved in, or actually tasked with preparing an Estonian Applied Research Center, RTO. Similar centers exist in most of EU countries. VTT is in Finland, RISE is in Sweden, TNO is in Netherlands. And when we started out with this work, we first had to motivate ourselves and others that this center is actually necessary. And if you look at this graph, it shows the productivity growth of EU in blue and Estonia in orange. And we see that in 2012, so roughly 10 years ago, we were, in terms of productivity, we were at 50% of EU average. And if you look at this growth further, we see that by 2035, we are still not at the EU level. If the historic trend continues, we are more like 90% of the EU level. But the goal set in the new strategy, research and innovation strategy, we aim to reach 110%. So obviously, if we continue the way we have done so far, we don't reach the goals. And there are a number of reasons, likely, why we still lag behind EU. Listed just a few here. And I think that in addition to excellent basic science done in the universities, additional focus on applied research is needed to translate these findings that we've heard in the past 2 days to actually into real products and services. The second, now that we have motivated ourselves and others that this center is needed to boost applied research, we set out to define focus areas for that research center. And our logic was similar in all 5 fields that were chosen. I'm going to talk about digital health in more detail. This is the first an overview of Estonian companies who are capable and eager to do R&D in bio and health sector. There are more than 140 companies in our list. And these companies, again, like the projects I showed you earlier, the main, the companies were divided into various technological niches or areas like bio-derived materials, e-health, microbiome, edible insects, and so on. These niches have, again, a global growth perspective in the x-axis. In the y-axis, this time you have their average R&D potential, and the bubble size is the total turnover of these companies in 2021. We see that 2 bigger circles pop out. One is dietary supplements with 9 companies and turnover of 42 million. And the second largest is e-health with 39 companies and 34 million turnover. Obviously, e-health is much more perspective in terms of growth potential, so it's highly prospective field. And e-health, as we heard yesterday here, also there's a strong research community in this field in Estonia. The sector does quite well. The turnover was 230 million in 2021, and it has grown year over year 1.42 times. So I think it's going well for the sector in general. And now, if you look at what's ahead in the digital or in the healthcare more broadly, Deloitte has suggested there are 6 trends going to affect the healthcare industry. And the ones marked with red stars are the ones where we see the most potential for Estonian companies and Estonian research as a whole. The first trend is data sharing. Obviously, it's important to gather the health data and be able to, in a quality manner, and also to be able to share it among various stakeholders so that you can develop meaningful solutions for healthcare. The second one is strictly related to the data sharing, is empowered well-being. Having quality data that is accessible, this allows to develop solutions that are help you to prevent and or cure the whatever problems you have. And the last trend is obviously scientific breakthroughs. As the technology advances, we develop more efficient drugs, we develop more efficient preventive solutions and these type of things. So all these trends, according to Deloitte at least, translate into this graph. We see that healthcare spending or spending directly on care and treatment is going to be flat over the next few decades at least. But where Deloitte sees massive growth is, they call it well-being focused. Essentially, spending on prevention, on healthy living and all these things is going to grow massively in the coming decades. And since we have a quite nice overview of the research done in Estonian universities on particular digital health, we have quite good understanding of what Estonian companies do in this field. I'm going to propose just a couple of possibilities or perspectives for Estonia, where we see that Estonia there's a huge potential. One is increasing the efficiency of new and existing therapeutics through combining sort of classical physical drugs with digital ones. Best examples would be anything related to mental health issues, where you take antidepressants which are physical drugs, and if you combine them with sort of some digital solutions, you can get increased efficiency in disease management. The second obvious example is obesity. Somewhat linked to this digital and classical drug combination is mapping and overall increasing the efficiency of healthcare pathways, meaning that I have, for example, some problem, I go to a hospital, I get cured or treated, and then obviously there needs to be some follow-up, and maybe I need to go again to the doctors, maybe I need to buy a smartwatch to monitor my health. This is very easy if you think about the technology is there, but currently, at least in Estonia, mapping these healthcare pathways and to ensure that people actually get treated is not that efficient yet, so we need to figure things out here as well. The second perspective for Estonia is digital therapeutics. A lot has been discussed or talked about whether Estonia should be a service provider or develop its own products geared towards end users. And digital therapeutics is one area where we see that there's a chance to develop end customer products. The market for digital therapeutics in Europe is expected to grow massively in this decade. And obviously the investments, the VC funding investments in digital therapeutics or digital health more broadly is growing massively as well. And obviously COVID pandemic boosted these investments even further. While in general, Estonia's digital government, digital health system is one of the best in the world. If you look at the digital therapeutics more specifically, we are not among the leaders, but we are fast followers, luckily. And the main challenge with the digital therapeutics and using them in Estonia is that we don't have a system yet in place that allows reimbursement for digital therapeutics. Germany has it in place, and if I'm not mistaken, the market for digital therapeutics in Germany grows like something 300% to 400% a year. So they're massively being adopted in Germany, and research shows that they are highly efficient. And the last perspective is somewhat linked to my previous years in the research, where I did drug development a lot. The number of challenges in the drug development, obviously we can collect vast amount of in vitro data in cell culture, in bacteria, or whatever. We can do less in EU, more in the US, but we can do animal experiments with mice or rats or ferrets or whatever animals. The challenge is that both of these models are very poorly predicting the outcome or very poorly predict what happens in the clinic if you develop a small chemical compound or an antibody or whatever drug. And here's again where classical biotechnology drug development can be linked with the machine learning, for instance, or other digital technologies. So you collect the data, you analyze it with some machine learning algorithms, and these can predict essentially what is likely going to happen in humans, whether you see off-target effects, whether you see some toxicity. These type of things can be easily recognized. And one of the first graphs I showed you was that the program has supported Estonian drug developer companies with over 14 million euros. If we link excellent research in IT and machine learning with the drug development procedure, maybe we can develop a first original drug in Estonia and advance it to the phase 1 clinic. And this again opens up a whole other perspective. We increase our competencies in phase 1 clinical trials, and so it's a huge boost to the industry in general. And I believe this was my last slide. Thank you very much.
Thank you. 1, 2 questions?
I saw that you are funding quite a bit of robotics and automation related projects. So what are the kind of robotics projects you have funded through this?
What kind of projects?
Yeah. And, what focus areas are looking in robotics?
Very diverse.
Okay.
You have the list of companies that have received funding is publicly on our website. You have projects related to autonomous vehicles, autonomous driving. In general, smart city applications, for instance, can be considered under the can also be either in this area, or depends on their focus. It can be also in the artificial intelligence projects, which are also quite often linked with smart city and autonomous driving. So, but again, very diverse. And the take-home here is that Estonian companies do very diverse R&D, and almost everyone is welcome to the program, minus if you develop alcohol or tobacco or these type of things.
I have one kind of question. So behind those, well, the list of companies is public who have got money, right? But the titles of the projects, or what kind of research they do?
It's also, there's a title of the project and a small description, short description of the project is also available.
Yeah.
This is just to, the point of this slide is to sort of more easily understand what's happening in which sections.
Okay, thank you.
Yeah, thanks.
We move on to Bogdanov.
Test.
Who has been also a member of the Scientific Advisory Board.
Yes.
Throughout the program.
I have. I was told I have 10 to 15 minutes, so I thought that what can I tell you in 10 to 15 minutes? How many of you are actually industry? Just asking for a friend. One person. Two, government doesn't count. Three, okay, three.
There were more.
So today I'm going to focus about how to get more industry in this room, because that was the problem I think I had for most of the time being the advisory board member. Come to advisory board meetings, we talk, I see all the problems, hiring, everything, this is hard, I understand. Then we try to give feedback. Feedback is talk to industry. Next time I come back, nothing has changed. Okay, I was exaggerating a bit. There are some things, the slides are getting better, we're trying to bring out the things, but the concrete suggestions that we had, talk to these kinds of companies, these kinds of industrial unions, this hasn't happened. So something has to be off here. And for now, again, all of the following part is somewhat in a humorous style, and I'm coming with the assumption that this is talking to industry, and industrial relations is something that university is looking for. This may not be what you need, by the way. Tartu University does industrial relations very well, I think. There are universities in Central Europe who I think it's forbidden for them to think about technical readiness level 4 or something. So in that sense, I don't think we're doing badly. The question is, what's the future like? If I look at the ministry's research strategies, then I think a lot of research is going into higher technical readiness levels. And there it's a little bit easier to do this stuff together with industry. So I'm assuming that there is an interest to do things together with industry. So that's how you have to start talking to them more. So industry people they're not like totally strange, but they have a certain communication gap. This scene is actually from a movie made after the same short story. So if you look at a business person, then you would like to talk to them about your research and understand what's relevant about that, and then you might run into questions, so how do I do that? What's the thing? Do I just tell them about my recent paper? Will that work? So today I'm here telling you that it might not really work. And these presentations we've seen here today are actually, they're I think the best I've seen over my advisory board member period. So congratulations. This is quite good. We have achieved a much better industrial communication. But yeah, if you meet a startup, there's a startup guy. You want to go and talk to that startup guy and ask them how to do things, and they're slightly different from you. Maybe they are also foreign, maybe they are from California, but there are some types of these people. So I'm going to run through 3, and I'm skipping government for now. So government is a whole separate thing. So how to talk to a startup company? Things to understand. They might need a lot of research, like a lot, especially if they are using words like deep tech, AI, or blockchain somewhere. They don't probably understand these words really well as you do, so you need to help them. The money, it comes from investors, and that makes it sort of ephemeral. It is here, then it's not here, then you raise the next round, and it's again here. So you have to find them once they've just raised a round, so they might have money to share with you in a great, in the best possible setting. And but if I'm looking at the world right now, and Mart had a beautiful graph about things going up. Right now, things are not going up in the venture capital space. It's not a good time to be in digital therapeutics. A major digital therapeutics company just went bankrupt a while ago, and its blood is on the streets on that market. If you're today trying to enter a digital therapeutics market with something data-driven, wellness app, it's going to be hard to raise money. Sorry, venture capitalists that did 20 funds a year now are doing 4. Means hopefully that there will be more people coming back to the university from startups who escaped and left their PhDs undone, for example. But right now, it might be the other way around. The startup people will be coming to you to go and ask money from Mart, Toots, from Enterprise Estonia, because they can't qualify on their own. They need you. So don't sell yourselves cheaply. If a startup comes around, wants to do an applied research project, ask them for the money. Don't sell yourself for 25,000 euros. Ask for several 100,000. Say that you have lots of research to do to support them in their business. Yeah. Because right now, the market is like that. It might not stay like this, but right now, this is startups need to survive for a few years until hopefully markets get better, and then it will be different again. But right now, yeah, talk to them and see, maybe you can help them survive. Startups are sometimes driven by visions, at least that's what they sold their investors. They are going to tell their investors that in the future that we are foreseeing nobody will drive themselves, and there will be a mesh network of cars that constantly talk to each other, and you need much less sensors, so we believe we are the next stage in mobility. Fair enough. So tell them that you like their vision and tell them that your lab is what they need to be successful, and then build from there. Depends on, again, the startup. They might be very strong about their vision, and they may not want to change. In that case, obviously, it's a bit harder, but try to buy into their vision. If you tell them about your recent paper first, that might not make a good match. So be interested in what they do and why they do it. And then sometime in the 5th or 6th paragraph, bring in the fact that, by the way, we've done a lot of research in that area and we found that, and then you have to make a mental jump how this relates to their business. Problem is they might be out to hire you instead, or your students. That's fine, that can happen. But again, if they want to do research with you, then try to, again, negotiate something for the university. It's nice. It's better that way for the university. Yeah, I stole pictures from some public ones. This is a startup founder. Shares the Hamming distance between my name and his is very small. So I see I have a startup founder in the family. We're good. So then there's small and medium industry. These are like most of the companies in Estonia. Your mileage may vary. They might need research. They might have a thing they want to build, they want to grow, but they might not. So lottery time. If you might meet some people, but several of them might just be in a business where they're selling development hours or something, and in that case, it's going to be very hard for you to claim why this is relevant, but maybe. There's a major difference here. The money comes from customers, which means it's much harder to get. And trying to get that money out of them is could be harder than with startups, funnily, because at some part in their life cycle, startups may actually have more money to spare on R&D. And so you need to create new customers for them, or you need to make servicing existing customers cheaper. Cheaper enough that working with you is not an opportunity cost. Yes, and you can try to, again, open slightly more pragmatically, less about the vision, because vision is important, but getting money from customers is a bit more important in this case. So we should learn more about your business. How does your business work? And then maybe a pilot or a joint R&D project. They might not be large enough to support R&D properly. That's a major problem. In that case, they will just do their programming and stuff and listen to you every now and then. And if this makes you happy, then possibly that's a way to go. But it might not. It might not get you where you need to go with this. This collaboration should get your research out there in the field. And in that case, you both need to sort of come closer to each other. And this might possibly be a hard case for that. Yeah, the hiring thing will be a risk again. And then there's large industry. If you ask whether they need research and whether they have money, then yes. All yes. But here the attachment thing is going to be way harder because they are as large as they are, then depends on how their technology adoption is built up. Some of them have really great technology ingestion teams. They talk to you, they understand very quickly what level of maturity you are, whether they want to let their strategic investment arm start a spin-off with you, whether they want to license your technology. Some of these big industries have very good people for that. Some don't. And in the case they don't, then you will not make it very far, or you will have to be there for years. But here the point is that if you want to make a match, you will really have to understand very well what their problem is. For example, the European Commission sets up these matchmaking events, putting you together with, I don't know, big automakers, Audis, BMWs, anyone, and then you go in and then you need to understand very quickly what their problem is. They very specifically want to solve something. They have a new line of cars coming out. They want to make these cars appeal to women so that women would buy them more, because their marketing tells them that women are not buying enough of our new electric vehicles. So we need to make them more appealable to female customers. So please, we're looking for every sort of technology or idea or thing that we can later put in our sales brochure that has some possibly scientific foundation on why this will increase our revenues. But here, sometimes the cool thing is that if you can somehow make Meta's conversion rates 0.7% more efficient with some of your cool new algorithms, then that will mean tens of millions of extra revenue. But you will have to be better, and you will have to have that edge somehow, and you will somehow need to be able to prove that edge. And that's going to be a bit harder. And the second problem is that big industry can take their time sometimes, much like governments, really. And you may need to still be there when they're ready for you. And that's one of the problems sometimes they have working with startups, but also with researchers, that they might come later and they might get to some deal when you've already moved on. But yeah, if this goes well, then they will try to hire you, your whole lab, and the university technology transfer department will be overjoyed. So possibly a great outcome. Yes, so I still have 2 minutes for questions, please. Question.
I do have one question.
Yes, I would have assumed so.
Your analogy to how to talk to girls.
Do
you believe in monogamy or promiscuity?
Me personally, as a human being, I have a very happy marriage for quite a long time now. Me right now, as a as a business person trying to get ahead in a technology-heavy business, I will talk to whoever needed to get my business bigger. And if this, I don't know, whatever, this cryptography team doesn't give me anything, then I will go to a next one.
But for long-term relationships
yes.
with a specific company, do you think that it's good to have eggs spread into many baskets, or how do you see the point? It's
Cybernetica is not a good example here. We have our own basket. We have our own R&D. Few others do. For them, you meant to have asked some the other three people who were industry here. However, I do think that closeness is very important. Just out of pure pragmatism, if I needed to do research, our research team needed to do something with a university, then obviously we're next door. Meeting somebody in this building for lunch, much easier than traveling to Lund. There's economics in play again. Depends. But if the guys in Lund can make the business 10x better, then I will go to Lund. Uli, I think, is in line.
So when I liked how you kind of end up with a big dilemma, which I think we are all facing here. So if we can convince the industry that our work is relevant for them, isn't there a huge danger that we are convincing ourselves as academics that we should be better in industry when we have managed that? And why should we stay at the university?
That's sort of what I began with. What is it? What's the thing? And if we talk about the IT Academy program and the government-funded research programs, then some of them have KPIs. Are you chasing those KPIs then? Because usually people get what they measure. In this case, in this IT Academy case, governments wants to measure collaborations with industry. So you should give the funding agency that because they are paying your wages. Very easy. Now, whether this is in the university's best interest or how you internally manage that, I wish I fully knew. I think you know better than me because you're the university and you somehow have to make sure you are ranking high in the Times Higher Education top, and you have to at the same time make sure that you have good industrial relations. I don't exactly know how I would do that. Jaak probably knows better. He tried to run for rector. So he has an idea, I believe, but this is hard, I think. If you focus on getting Nobelists, you might get Nobelists. In the end, how you fund that is a very difficult question. In Estonia, I don't think you can fund the university like that. And the ground might be shifting underneath towards the industrial thing. But how to do that while maintaining a good research quality is a great question to be solved in the coming 10 years. Yeah.
Yes, I have a question. So I didn't really understand the message of the presentation because it seems that, okay, we have a formula, and this formula, well, there is a lot of aspects to apply so that it works. And sometimes it works, sometimes it won't work. It seems sometimes promising to stay in academy, sometimes, go to research. But then, for instance, in the case of staying in research, why we stay in research mostly is because we want to make impactful research. So yes, some companies, they have industrial teams, but then the research which they produce there is not, like community focus or community, breakthroughs. And then, for instance, bring in some of these researchers to work to industry. Well, that is not going to happen because, of course, that's why they build their profiles. You end up working with researchers in industry that. Well, they know how to do the research, but there is no much, breakthroughs to build beyond what the industry product is. So then, So then, what will be the formula to apply here for like going to research, going to industry, consolidating both?
I don't think I try to paint it as a do research or go to industry. I don't think I ever suggested going away from the university. I think I very specifically tried to say today how to stay in university and talk to industry.
Shall we us talk to them or they talk to us?
If you get funding, which has a KPI of talking to industry, you talk to them.
The industry that, like approaches, like, of course, they're business oriented, and then they will be like, okay, we will pay you for do this, but these are pennies. I have more luck applying for funding at the EU level that I will get more money, and not, like just working for 100K.
But you're funded under the IT Academy, no?
Yeah. But as well, I have getting proposals in EU.
Yeah.
So,
very good.
Yeah.
So this is actually an offline discussion. I think we're like, it's getting into an interesting follow-up here. And I'm running out of time, by the way.
We have some time for further networking.
Yes.
Okay. I think we have to move on to the next speaker, and thank you. And next is Petteri Nurmi from University of Helsinki, North Tallinn.
All right, hopefully you can hear me well. So instead of giving insights, I decided to spend this opportunity to advertise my own research while giving some insights, hopefully as well. But then the more critical insights may be left for a later point. So I'm going to talk about pervasive data science and environmental sustainability. So one of the strategic research areas for the University of Helsinki in recent times has been to kind of marry our emerging research areas of data science and life sciences. So there, within that, we're then started looking on how can we use computing technologies to support life sciences in different forms. And where I specifically have been working on is environmental sustainability. And just very quickly, what do we mean with that? Because everybody has heard the term sustainability, but actually, if you ask 3 people what it means, you will get 3 different definitions. So sustainability means, in general, that we live in accordance with our resources and we don't overspend them. And there are different pillars of sustainability: economic, social, and environmental are some of the most important ones. So environmental sustainability then refers to keeping our environment in good shape. The most dangerous factor to our environment is pollution, and generally pollution comes from humans. And if you think that just making humans act better would solve the problem, unfortunately it's not so simple. So here is one example from plastic on the life cycle of plastic. So say that we have we have a normal water bottle that we buy, then we might throw it or recycle it normally, then it ends up in a landfill, or somebody can throw it on the ground, in the nature. Then regardless of whether we do the right or the wrong action, what can happen is that birds, the weather, or whatever, can transport some of the plastics. They might end up on beaches. They might end up in waterways in the end. So this is the plastic reef at Bali. So if you go diving there, you can see something else than fishes. So there's a massive kind of circulation of plastics. And then eventually these things break, what is known as microplastics. And that's one of the bad things they say in research these days. You can also say it's good. So every one of us apparently is eating roughly 1 credit card worth of plastics every week. So it's a bad thing for our health, but at least everybody has a credit card per week. So as that example a little bit already indicated, the problem in solving this in a more long range is that, well, obviously, if anybody had solved that, we wouldn't be hearing about the climate being such a big issue all the time. But one of the things that makes it so challenging is that all these ecosystems are so interlinked. I already mentioned that even if you have a normal plastic bottle and then you just throw it away, it can still end up in water. and it can go there through the ground, or it can be ending up there because I threw it there. No, I wouldn't do, but maybe you would. But anyway, so in order to understand this effect, and in order to mitigate, we actually need to monitor all different ecosystems: water, ground, and even the air. So one of the things that is done on plastics is that they are being burned, and that burning process results in harmful chemicals which then pollute the air. So the long-term vision that Microbe pursues is about doing this kind of interlinked monitoring of different ecosystems, and within that, the key research directions are developing low-cost sensing solutions, both from the side of repurposing sensor solutions, developing algorithms for processing that data, so kind of data scientific aspect, as well as then doing some kind of systems for monitoring waste and pollution, how it's been accumulated in the wild. And there are some examples of some of these topics that we have done. Some of them are in collaboration with University of Tartu. So marine plastics is one of the areas. So there we've been working with University of Tartu and University of Madeira, and among others. Food waste, waste recycling, and air pollution, all are examples of these different areas of environmental sustainability that we're looking at. So as one of the highlights, something that you might have seen earlier, produce quality estimation using smartwatches. So the idea is that you basically take your watch, you put it on a tomato, and then it says, is it good or bad? So this is how it started. But then the big challenge is that in order to adopt these technologies, you have to think about a little bit on whether this could be adopted in other parts of the chain. So then you look at what is the overall life cycle from a produce, from like cultivating it to transporting it to actually finally having it in a store and then consuming. So in order to adopt these technologies and in order to have the final impact, you have to start from somewhere. But you need to also have a sufficient grounding that you can assume that this technology could be adopted over on multiple different stages of the chain. And some of that research, for example, Huber has been doing on how to adopt related technologies that based on this in different parts of the product life cycle. Another example I want to mention is about supporting scuba divers. So one issue with this monitoring is that collecting data about the environment has been notoriously tricky. So nowadays we have much more sensors in the environment, so some environmental parameters you can get much more easily. So I assume here as well, but at least in Finland, everywhere you go, you see an air quality map. And usually it says that it's still pretty good, but okay. But then there are certain areas, such as oceans, where collecting data is still very difficult. So some people say that space is the last frontier for computing, but actually we get more data from space than we get from waters. So here, one of the things we've been slowly building up is how can we provide something that scuba divers, recreational scuba divers, could produce data that then marine scientists and environmental agencies could adopt. And there, the challenge is that we need to have the sensors underwater, we need to have the necessary computations, and we need to have kind of supporting elements for the divers. So one of the works was this thing, which is these kind of data centers that work underwater in these kind of bubbles, but actually they also have sensors inside of them. So the kind of idea is that you have the sensors there, you find some trash underwater, and the scuba divers can take it there, and you can get immediately analyzed and then say, okay, this is very dangerous, please help us remove this. And as well, that way, these people get educated as well about what is there underwater. Another part of it is that in order to do this more systematically, you need to have information about how to localize the people underwater. So some of the work that we've been doing relates to doing underwater data reckoning. And here, so this dead reckoning refers to navigating based on a known starting position, then you know how far you're going, which direction you're heading, and you keep updating it. So this has been studied a lot in robotics on the ground, but once we go underwater, it's not so simple. So here's one example of a trajectory of a diver from coming up from the bottom using one of these techniques. So it's somewhat accurate, but there are still issues. But generally, the point is that once we bring these techniques that might be very well established somewhere on the ground into underwater, into new settings, actually we notice that they might not work so well, so the optimal algorithms for the underwater settings are different than those that work on the surface. Yeah, so that's about all I have about the research examples. So then once you start asking about adapting these techniques, so yes, that's something that we're also been working on. So one of the challenges you have in these kind of fields is that you want to work together with the life scientists, or you want to work together with companies. And from that point of view, they might have a data set, or they might have some specific problem, but they usually expect that you come with a ready-made solution. And it's very challenging to come with a ready solution to something that they have been doing for 30 years. So in that way, you have to be able to take this kind of baby step, so to say, progressively build on your vision and make it more and more realistic. And that way, we have started getting more into collaborations with environmental scientists now in fields. But at the same time, you also should look into collecting data sets, getting access to laboratories and so on, so that you can build more impact. So that's the other problem, getting access to right enough data. So data is the new oil, except oil still carries your car, data doesn't. But in research, you get more value out of data than you get from oil, unless you use the oil to fund your research. So with that in mind, maybe time for some questions. Thank you.
Thank you. So while we have in here audience, later we will have some smaller scale in more private setting. Can you say something about IT Academy, the way how we have been running the recruitment strategy in here and comparison to Helsinki University Computer Science Department, for example? Can you do some comparison? It's not easy, but yeah.
So in our case, the recruitment strategy has been largely based on profiling of the universities. So they looking into specific research areas and kind of specializing a little bit, creating a difference between which universities do which kind of research. And within that, then we have been trying to look at synergies, because the University of Helsinki is a big animal, has some things that some other universities do not have. So then can we do some synergies from combining these excellent labs in life sciences, for example, with computer science, rather than try to do computer science in every aspect. So I think that's something that I didn't see so strongly discussed, than that kind of the profiling aspect of what is the unique or the main strength for the IT Academy, and how we could possibly build on some already existing labs and support, like build synergies between them, if that makes clear.
Maybe some were not mentioned explicitly, but implicitly some were there, of course. But yeah, okay. I think this wraps up the presentation part. And before we go for, was it a coffee break? I will take a couple of minutes to summarize a little bit what we witnessed in here in these two plenary sessions. So if I may remind you, then Jaan Aru, I gave the brief introduction to IT Academy, but then Jan-Aru told us about the new general in the room, a personalized trainer. Then Hubert Flores was enlightening us where the data comes from, all the sensors and applications related to that. And take-home message, protect your drinks at any cost. Raivo Kolde said that, well, basically told us that we need to make the data to look similar in order to do broader data analysis across different data sources. Then Arnis Barshovs demonstrated us all the different ways how Estonian ID card infrastructure has been broken over the years. We are even not aware of all those incidents always, but this has been a great trajectory of his research. This morning, Arun was developing these strategies to work in the unknown places. I did not ask whether these are known unknowns or unknown unknowns, popularized by Donald Rumsfeld, so you can discuss about that. And he was about the only ones who dared to show some formula, very briefly, and then put away. Eduard Ševtšenko by far had the densest set of slides. We could not read any of that, but we were convinced that there are lots of detailed processes behind all these digital supply chains. And then Naveed, I'm not even sure, did you kind of said, relax, you will still be driving your cars for next 20, 30 years, right? There must be some rallies, off-roads, and all the fun that you can have with the cars, even if the roads are autonomous only. What I was surprised and did not ask about is this, in what ways our laws are flexible? You don't need to answer that. We don't want to have this flexible legislation, flexible approach to the data privacy. And then Mart gave overview. Some of you may not have been aware of all these applied research programs in Estonia, how they are developing currently. Then Dan Bogdanov taught us how to talk to girls, petite and large, young and old. And Petteri and Nurmi reminded us about what we all need to do, think about sustainability into the future. So with these plenary sessions now are over, but we will have coffee break. We will have this speed dating thingy. Registration on the web has been closed, but it still can be ongoing on the paper. Marianne Levi is somewhere, are you in the audience? Back there. So if somebody is still missing out, then there is on the paper, you can still agree. This is taking place on the 3rd floor, and we will be running the bell every 15 minutes, right, Marianne? Okay, and then the posters are still up, and I hope that the research groups are, during this second poster session, still available, maybe in lesser quantity than yesterday. And on parallel, we will have a closed session with the advisory board members. So you will have opportunity to have coffee, networking, posters, lunch, and this concludes the event for most of the people. But then PIs are expected to be back after this advisory board meeting so that we can have a small reflection plus stakeholders of this IT Academy program. Okay, any questions? Are we clear how everything runs now from here on? Thank you everybody for coming, and let's go to the coffee and further networking.